questions on it. So we're going to start with, this is the first part. I'm on like page 1 through, it goes for a while. Whatever, the first part, that is non-calc. Any questions on the multiple choice non-calc? Reagan?
Number 3.
Yep. Okay. So number 3 says the function f has the end behavior described above. Which of the following could be an expression for f? So first of all, the end behavior is as it goes to negative infinity, it goes to infinity. That means it's going to rise on the left. And as it goes to positive infinity, it's going to go to 0. That means there's a horizontal asymptote at 0, right? Because otherwise, what would make it stop? So I just went through each of the 4 options and plotted what they should look like. It would be, I would say, anytime exponential question like this happens, God bless you, I tend to draw a picture. Especially because they could ask you increasing, decreasing, concave up, concave down, end behavior. They could ask you any of those things. So if it's a 1/2, it means it's a decay, but it's got a negative on the front. So typically my decay goes like this, but the negative flips it upside down so it looks like this. So my left-hand behavior is going to negative infinity. I would rule it out. Go to the next one. This is now a growth, so it would normally look like this, but it's got a negative on the front, so it flips upside down. Left side is 0, right side's negative infinity, doesn't match. Go to the next one. This one's decay, positive 3 on the front. So decay means it's going to the, like down onto the right. So the left-hand side is increasing, the right-hand side is approaching 0, where that horizontal asymptote would be. That's the first one that matches. Just to double check, do the last one. This is growth, positive, which means it would increase as you move to the right. So the only one that matches there is C. If it asks you to describe if it's concave up or concave down or increasing or decreasing, this specific one would be what? Increasing or decreasing? Decreasing. And concave up or concave down? Concave up, good. So rate of change is good, increasing. Yep. Oh yeah, on this page? If the A, remember it would be a vertical shrink. So the only thing we worry about the A on, if we're doing behavior on the ends, is it positive or negative? Okay. If it was a fraction, it would just mean it's a vertical shrink. So like a vertical compression. Wouldn't affect my end behavior. Okay, yeah.
Wait, what's the rule with B?
If B is bigger than 1, it's growth. And if B is in between 0 and 1, it's decay. Okay. Yep. When in doubt, plot a point. Right? When in doubt, figure out what happens when you plug in 0 and you plug in 1. You can kind of get your shape. But if you get stuck on it, like I wouldn't, so this, especially the first time through, if it's going to take you more than 2 to 3 minutes to do a problem, flag it and go back to it. All right, 4 says the value of a new car modeled by a function C. The value of the car is expected to decrease by 19% each year. At time t equals 0, the value of the car was $30,000. Which of the following expressions gives the value of the car after m months? So first of all, the t equals 0 means that's my initial value, right? If they had looked anything different, like any of them started at something other than 30,000, I would know to rule them out. They all started 30,000. So now we're going to the next one, and the next one is a decrease. If it's an increase, it'd be 1 plus it. If it's a decrease, it's 1 minus it. So 1 minus 0.19 means that the base has to be 0.81. Now I've ruled out A and B, okay? Then think about, this is a specific number of times a year. So, a number of times a year. If it's happening monthly, then it is 12 times a year, right? So we put, the T was the original equation. So if you remember, you had your exponential, you had number of times a year. Those equations you want to make sure you review if you haven't. But it is T over the number of times a year. Because it's the initial formula. So our initial formula, which is your initial value times the rate, raised to T, is an annual formula. That is if it happens once a year. So if it happens more times a year, you take that T and you divide it by the number of times a year.
So, like, if we multiply 12 by n in that question, what would that be like?
If it was 1/12 of, so if it only rolled over every 12 years, so you wouldn't do it. Yeah.
So wait, do you remember what like notes that were?
If you go back to your review, this is exponential, so this is in unit 2. Yeah. It's on your reference sheet. We did the double formula, the half formula, the PERT, and the number of times a year, all 4 of those formulas. Well, I don't know that we did a half, but we did double, and we said if it was a half, we would just change it. Yeah.
Yeah. That's
6 is at the bottom. Okay, 6 says, what's the value of the expression log base 2 of 8 plus log base 1/3? If you look at your answer choices, none of them have a log, which means this is something that I can simplify, right? So 2 to what power gives you 8? And that answer is 3. And 9 to what power gives you 1/3? 1, it moved to the bottom, which means it has to be negative. 2, it went from 9 to 3. That's a square root, and a square root is a fraction. So 9, and if it confuses you, rewrite it like log base 9 of 1/3 equals what? Now convert it to exponential. 9 to what power gives you 1/3? If you want to change the base to be the same, you could rewrite 9 as 3 squared raised to the x power, and then 3 goes to the top, it would be a -1. Now you can set your exponents equal to each other. 2x would equal -1, and x equals -1/2. It's faster if you can ask yourself, what would I raise 9 to get to 1/3? If it has moved to the bottom, that means your exponent has to be negative. And if it got smaller, it means you're taking some sort of root. If it was 9 to 3, that means it's a square root, and a square root is the same thing as a half, and then 3 minus a half would be 6 halves minus 1/2, which is 5 halves. Yep. 5 says, you've got a function -2 to 8. The function g is defined by g of x equals 3f of 2 times x plus 4 minus 1. Which of the following gives the domain of function g? So first of all, domain means x. Only things inside the parentheses affect your x. So only this stuff is what I'm worried about. If it had said something about your range, I'd worry about the 3 on the front and the -1 at the end. Inside, domain, outside, range. Because inside is x, outside is y, right? Okay. So I have to take this and figure out what those variations are. This, the 2 on the front, is a horizontal dilation by a factor of the reciprocal. So horizontal factor of 1/2. Which means I'm going to take my x values, which is the domain, and multiply it times a half. So I get -1 is less than x, which is less than or equal to 4. Then the plus 4 inside the parentheses is a horizontal shift, and it's the opposite direction. So a plus 4 means I move it left 4. Left 4 means I'm going to subtract 4 from these, and that's where the -50 comes from. Yeah. Okay, 6, it says, wait, is this 6 at the top?
That's 7. That entire question is 7.
How about next page? 7, everybody was good on 7. We just switched the x and y values, yeah? Okay, 8 and 9 we're good on? 9. 9 says you've got a rational function, which is the following, which claim is the statement about the statements is true. If you look through your answer choices, because I would to see what we're looking at, they're all about the horizontal asymptote. So horizontal asymptote means we look at the highest exponent in the top and the bottom, and that's your n and m, right? If n is bigger than m, there's no horizontal asymptote. So if you look at the choices, this one has a horizontal asymptote, cross it out. This one has a horizontal asymptote, cross it out. Now I'm down to these two. And it just says it does not have a horizontal asymptote because the degree of the numerator is greater than the degree of the denominator. That's the right answer. Because the leading coefficient is equal to the leading coefficient, it has nothing to do with it.
I just forgot.
Yeah, so review them. So bigger, none, equal, leading coefficients, less than, 0. That is also like next week's stuff. Like we're going to do it again. You're going to get pulled that when we get to limits. One bigger is slant. Yep.
only if they ask you.
But it didn't ask you anything about slant. Yeah. I'm going in order, so hang on. So 10 through 12, any questions there, Mariana? 10. Okay. 10 says the function k is given by cosine of theta plus pi over 3, where 0 is less than alpha, actually, which is less than pi over 2, which of the following is the equivalent form of k of x. This, I said it last week, but I was like, we haven't done sum and difference in a long time. Make sure you look back over sum and difference. It's like God in your lap.
I didn't know they could
Okay.
go sum and difference like that.
Sure. It's cosine of a sum, right? Even though it's two angles and there's one unknown. So we'll expand it. Cosine's pattern is cosine, cosine, sine, sine, and we change the sign. So I would make it cosine alpha, cosine pi over 3, minus sine alpha, sine pi over 3. And then you actually know the value at pi over 3. Pi over 3's coordinate point is 1/2 and root 3 over 2. So the cosine there is 1/2, the sine there is root 3 over 2, and you plug those values in, and that was B. All right, we go down 11 and 12. 11 says the polynomial p is an odd function if p is positive and increasing on the interval. Okay, this one I thought was tricky if you don't remember even and odd. Even means that it's symmetric to the y-axis, right? Symmetric to y-axis. So if it had said the same thing, but it had said it was even, then I would have taken all these values and flipped them over the y-axis, and I would have figured out the answers from there. Because it's odd means it's symmetric to the origin. So everything that happens in the top right reflects down on the bottom left. You literally change the signs on the x and the y. So if you had if it was going up here, right, it means it's flipping and going down here in the opposite quadrant.
Could you also remember if it, the way I kind of thought of it was like x to the third power? Does that work too?
Yeah.
Oh.
Because that is symmetric to the origin.
Okay.
Yep. So if you wanted to draw it, to picture it, that's totally fine. Yeah.
So would we just like, so it says P is positive and increasing, we just find one where it's negative, oh wait, no.
Well, it says it's on the interval of 2, it's positive and increasing, and it's on the interval of 2 to 7. So then we flip 2 to 7, which is in the positive in the first quadrant, and we flip it down into the in the third quadrant. It goes the opposite quadrant. And in those x values will be negative. Yep. Yeah.
What are the differences when you have an vertical asymptote and a whole? How do you determine that?
If it cancels completely from the bottom, there's a hole. If only, like if it's raised to, so for this example, right, for number 12, you canceled out the 5 completely, that's a hole. We canceled out one of the x minus 4s, so there is still a vertical asymptote there. You canceled out the 2 plus 2 completely from the bottom, so it's a hole.
And what if you had like 2x plus 5s on top and 1x plus 5 on the bottom? Would there still be a hole?
No. Yes, if you're canceling it completely, which is that's the x minus, the x plus 2, right? X plus 2 squared is in the top, x plus 2 is in the bottom. So you canceled out the x plus 2 in the bottom, that creates a hole. Good. 14 says they use a linear regression to create the model. The figure shows the residuals of the linear regression. Which of the following statements about the linear regression model is true? Remember, if there's a pattern, then there's clearly a pattern here. If there's a pattern, it is not appropriate. So no pattern appropriate, so not appropriate because there's a clear pattern.
And that's only
For
for regressions?
residuals, yeah. 15, 16? 15. 15 says, let 2 sine cosine and g of x equals 2 sine cosine and h of x equals negative sine in the xy plane. What are the x coordinates of the intersection of the graph for g and h? So intersection means set it equal to each other. So I set it equal to each other. As soon as you see there's a mix of trig functions, know that you're going to want to get them to one side. So I moved it over to one side. You could have also done your double angle formula here. Yeah, I don't know if it would have been as easy, but I got everything to one side, so I moved the sine of x over to the right-hand side, and then both of them had a sine, so I factored out the sine, and then I split and solved. Sine equals 0, and 2 cosine x plus 1 equals 0. Sine of x equals 0 at 0 and pi, and cosine of x equals negative 1/2 at 2 pi over 3 and 4 pi over 3, which was D. Yeah. 14, go.
It doesn't matter if they say like linear regression or exponential.
Whatever it says it is, you just want to see if it's appropriate or not.
You just want to see if it has a pattern.
Right.
It doesn't
Yeah.
matter.
So they could also, we've had a practice problem where they gave you 2, like a linear and a quadratic, and the linear does not have a pattern and the quadratic does. Now you know linear is the better option. The one without the pattern is the good one. Yeah. All right, questions on 16. We go on 16. So you had to find the rate of change there. Okay. 17, 18, 19. Questions on these? 19. 18 and 19. Okay, so 18 says the number of customers inside a fast food restaurant during lunch can be modeled by the function given by, and it's a cosine function where t is time since it began, but in minutes from 0 to 30. Which of the following is the maximum number of customers inside the fast food restaurant? Well, this is a cosine. It has a negative a, right? So if I was to actually estimate what it looks like, it would be a negative a, it would come up and it would go back down again. Either way, your max is going to be your amplitude plus your vertical shift, or your D, right? Your midline. So 52 plus 27 is your max.
But I thought you said like max is only A plus B.
D.
Oh, it's A plus D.
Yes.
Um,
Yeah, you're thinking polar.
A plus.
Absolute value of A, really. Absolute value of A plus D. Because it would be your midline, which is 52, wherever that is, plus the amplitude, which is 27.
And you can do the opposite from it.
Correct. It would be midline minus amplitude. Okay, 19 says the polynomial h is shown. It is known to have complex zeros at 2i and 3 minus i. What's the least possible degree of h? So what's important here is to remember that complex zeros comes in pairs. If I have 2i, I also have negative 2i, which means there's the answer there. If I have 3 minus I also have 3 plus i. So there are 4 complex answers. And then when you look at your graph, there is 1 real here and 1 real here. This is an odd multiple, so it could be 1 at the minimum. This bounces, so it has to be an even multiple, which means that the minimum it could be is 2. So 1 plus 2 plus the 4 complex would be a degree of 7. You have to remember complex answers come in pairs. All right, 20 to 22. 20 says a portion of the graph is shown above where the period of the graph is 11. What's the value of 42? So even if you just looked at your graph, like it tells you the period is 11, but also if you looked from the middle point here to the middle point on your pattern, again, it is from 1 to 11. So we did these, it's been a little while, but you remember we would just keep duplicating. The last number becomes the first number. So if it ends at 11, then the next one would start at 11. Then it would start at 22. Then it would start at 33. Then it would start at 44. And you want to figure out 42 is in between 33 and 44. So I literally wrote the numbers out. 33, 34, 35, 36, 37, all the way to 42. And then I looked at the y coordinate on the 42, which was 2. So whatever it ends on is when it would start again. Yeah.
You just go backwards from that point to.
Yeah, like if you know it ends at 44, you could go back to. It's the same thing. Yeah. Yeah.
Wait, so at 1, if it started at 11, I would count.
11 starts it again. So it stops at 11, but that means that 11 would also be the start again. So the last number in the period is the first number of the next period. So we did multiples of that number. 21 and 22, good on those? It says 22 says an exponential function is given by negative 3. So this is, think about what we just talked about, right? 1/2 means decay. So it's falling as you move to the right, but the negative 3 flips it. So now it looks like this, and that function is increasing. And because it's on that N shape, it's concave down. I have to draw those out, and I would say to do the same. All right, 23 and 24. 23, you guys said, right? 23 said let the function, so f is given and g is given, and it says f over g. So I put f over g, and then I factored it, took out an x, factored it. So in complete factored form, it looked like this. X times x minus 5 times x plus 2 over x minus 5 times x minus 1. And then the x minus 5's canceled out. It canceled completely from the bottom, which means there's a hole at 5. There is still a vertical asymptote at x equals 1. So if I needed to know that, I would know that. And this case meant that my remaining function was this, x times x plus 2 over x minus 1. If I distributed the top, I would have gotten x squared plus 2x over x minus 1. And because the exponent is 1 more than the bottom, it means there's slant, right? So if there's slant, now I've got my vertical asymptote at, what was it, +1. And then to find slant, you divide the top by the bottom. So I did it synthetically over here, but you could do synthetic or long division. And I get y equals x plus 3 is my slant asymptote. And I also had 2 zeros. So from here, I know the zeros are at 0, -2. 0, -2 tells you your graph is going in this corner and in that corner. So where is it greater than 0? From -2 to 0, it was greater than 0. And then again, after the vertical asymptote, which was 1. And then it had a hole at 5. So it stops at 5 and starts again.
So you have to.
This one took time. I would say this is one I would say that if it throws you the first time, flag it, keep going, come back to it. It's not that you can't do it, but it definitely took a little bit of time.
So did I even need to solve for the slant asymptote? Because you're using everything.
As long as you understand what your graph looks like for me, without the slant, the zeros were weird,
Okay.
right? Because if you just draw your vertical asymptote at 1, you had 2 zeros. So unless you understand why that's happening, that's a weird shape. It's happening because there's slant. You don't have to know where slant is, but you do have to know that that's what's causing that little weird. Otherwise, normally our graphs go like this, right? So you have to understand that it's not a horizontal asymptote, it's a slant.
And you have to consider the whole.
The whole affects your domain. Sure, because it's undefined there. So if you remember when we did whole, like when we did the order here, the very first thing we did was factor everything out, find the domain. Domain comes first. Then find your whole. Then find everything else. But the domain comes from before you find your vertical asymptotes. Before you cancel things out. 24 said it has a vertical asymptote at x equals 1 and a hole at x minus 1. So that means I don't know why I just did that. It means in the bottom I've got an x plus 1 at the end, right? And it means at some point I had, an x minus 1 because it's a vertical asymptote at the end. And it means at some point I had an x plus 1 in both the top and the bottom. So when you look through your answer choices, there were 2 like that. They had an x plus 1 and an x minus 1 and an x plus 2 and an x minus 1. The difference is the sign. So in order for it to be negative, right, because it says what? Which of the following could be this expression? If you were to plot, even if you were to plot a single point, you would see that on the left, like if it was negative, that's when your point would have come down here and gone up here. That's one thing. You could have also looked at your horizontal asymptote. Your horizontal asymptote was at -1. So what's going to cause a -1 would be a leading coefficient that's negative, and that's why A was the choice.
So what is a positive? Is positive the other way?
Positive would have been the other way. Yeah, but you could have also you mean like if there was a horizontal asymptote at +1, then I would know my leading coefficients had to give me a +1. So the leading coefficient here was -1 over 1, which is why it's a horizontal asymptote at -1. You could have also plugged in a point. Yeah, I could have narrowed it down to those 2 and plugged in, let's just say plug in -2 and see what happens. Am I in the right spot?
I think 0 is better.
0 works too, yeah. All right, 25, questions on 25, yeah. All right, we're good on 25? Okay, 26 and 27. 27 is asking you for an additional representation of that point. So remember, there are 2 tricks to get that. You either keep the r the same and you take theta and add and subtract 2 pi, or even multiples of 2 pi. Or you change r and you take theta and you add and subtract pi, or odd multiples of pi. So if you looked at the answer choices, the ones that kept the r negative were not plus 2 pi or minus 2 pi, so I ruled those out. And
How? I thought but those answer choices are -3 pi.
so if you keep the r the same, you have to add and subtract 2 pi.
Oh, if you flip the
If you
sign.
flip it, you do it. You could also plot all 4 of those points and see which one overlaps.
Okay.
So if that's easier, 5 pi over 6 is here, 5 pi over 6, right? And it's a -3, so the initial point is in your 4th quadrant. So then 7 pi over 6 would be here, -3 is here, that's wrong. 7 pi over 6, 3 would be here, that's wrong. -3 and 11 pi over 6. 11 pi over 6 is over here. -3 is over here. That's wrong. The only one that works is 11 pi over 6, 3. That's the only one that overlaps. So you could also do it that way if you want. Yeah.
For 26, would it just be exponential if it was like,
Exponentials if the x values are increase by the same additively or by the same amount, and the y values are proportional. If your x values are proportional, it's a log. That's the only time that happens. Yep. 28 was your polar function. You want me to go through this one? So let's talk. Didn't you say, can I go? Oh, it's Andrew, can I go over Limbisons? Yes? Right? So the question came, is there going to be a rose or a Limbison? Guess what, guys? I don't know what's on your test. Could there be? Certainly. Okay. So if it's a plus b sine or cosine, right? Cosine. This is your Limbison. If I could spell it. Well, that's an I and an M. Okay. If it is, and then you do A over B, and we ignore the signs, right? If it's less than 1, inner loop. Equal to 1, cardioid. In between 1 and 2, but not equal to either of them, dimpled. And greater than or equal to 2, convex. That's a flat one. So then I would do A plus B is your max, and A minus B is your min, and then I would set them equal to them and see which one it is. You also want to know that sine is symmetric to the pi over 2 line or the y-axis, and cosine is symmetric to the polar axis or the x-axis. So as soon as you look at this one, you know it's sine because it's symmetric to the pi over 2. That rules out C and D. And then in each of those cases, the max and the min are the same. Your max is out here, which is at 3. Your min is here, which is at 1. But that doesn't help you narrow it down because those are also the same. So then I literally would have just plugged in a point. You can set it equal to, or no, I set it equal to the max and the min to find where it is. But you could also plug in a point. You could plug in pi over 2 and see what you get. Like 1 minus sine pi over 2 is 1 minus 2 times 1, 1 minus 1. So at pi over 2, it's -1, and that aligns with what it is. If I did 1 plus 2 sine pi over 2, I get 1 plus 2 times 1, which is 3. And at pi over 2, it is not at 3. So you could have done that. I found the max and min, set it equal, and saw what happened, but you could have also plugged in a point.
Couldn't you just look at the reflection?
yeah, that's what I did.
Yeah, that's fine.
I saw since it was a -2, then I just went down.
Yeah.
That's fine. But if there, let's just say there was 2 -2s and the values were what was different, I would just check. So I would keep all those like ways of checking in your back pocket. All right, now we move into the calculator part. So 78 said the complex number is represented by a point in the complex plane. The complex number is the rectangular coordinates -1, 3. Which of the following is one way to express the complex number using its polar coordinates? So first of all, the r was the same on all of it. I could kind of skip that part, but r is equal to the square root of -1 plus -3. And that would have been root 10 if any of that was different, okay? The other thing is all of them had cosine on the real part and sine on the non-real part. If one of them was switched, I would rule it out. Cosine is your x, which doesn't get the I. Sine is the y that gets the I. So then the next thing you got to do is figure out where this is. -1, 3 is in your second quadrant, right? So then think about, these are not in terms of pi. These are in terms of radians. If you had done, this would be 0. This would be 3 pi over, or 3.14, and it would double back to 6.28. So if I want to be in this quadrant, if I did no other work, I would at least know that if I was in that quadrant, I would want to be in between half of 3.14. So what is that, 1.6-ish? I want to be between that and 3.14 because I want to be in the second quadrant. 4 is too big. -1.24 is too small. So now, and even the 1.29 is too small. If I just did that, I would know I want it to be the 1.93. The way you find it exactly, though, let's say there's 2 within that range, is you're going to do the inverse tan of the y over the x. I ignore the sign the first time because it's going to give me a negative angle, right? The negative angle is here. I need to find the reference angle, or that's your reference angle, and I need to figure out what quadrant it's in. So I ignore the sign the first time. Y over x would be tan negative 1 of 3. And when you do that in the calculator, you get this is the reference angle though, 1.249. First of all, I would know that's first quadrant, so it's not right. But I want to find the angle that has that as its reference angle in the second quadrant. In the second quadrant, you do pi minus the reference angle. So pi minus 1.49 is where 1.893 comes from.
Wait, you do pi minus.
Yeah, because so the reference angle just tells you, it's almost like that's your pi over 6 or your pi over 3 or your pi over 4. But now you got to put it in its right quadrant because it's definitely not the first quadrant. So, because they would both, x and y would both be positive, right? I got to move it to the second quadrant. So the rule is if it's in the second quadrant, you do pi minus the reference angle. Third quadrant, pi plus the reference angle. Fourth quadrant, 2 pi minus the reference angle. In the first quadrant, you leave it alone.
Wait, the second,
No, you.
the second quadrant, they're both x and the y has to be positive?
No, in the second quadrant, the x is negative, the y is positive.
Then how come for C, they're both positive?
Because the angle cosine of 1.93 will be negative.
They will, okay.
Yeah. You could also work backwards on it.
Can I just do it the way that, like, estimate it? Then-
Sure. This is a question that you could also work backwards on, right? I could do square root 10 of cosine of negative 1.249, and then square root of 10 times the sine at negative 1.2, and then find out, am I getting negative 1.3? Like, you could work backwards on it. Yeah.
That makes more sense.
All right, 76 says a geometric sequence has terms g of 4 equals 9 and g of 7 equals 30.375. Find the value of g of 12. Two ways to do it. One, literally plug those in as your x and y. So 4, 9, and 7, 30.375, and run an exponential regression. So you have to know geometric means exponential. Run an exponential regression, and then do y1 of 12. That's the easiest way to do it. The other way to do it is the big little one. So it's the big, right? So A of the big equals A of the little times B, big minus little. So if I do that, the bigger base is 7. So A7 would equal A4, and it's G's, but the same, it doesn't matter. And B to the 7 minus 4, which is to the third. Then plug your values in. 7 is 30.375 equals A4 is 9, B to the third. And then I would divide both sides by 9, and then I would cube root my answer. That's going to give you B. You still then have to find the 12 by either setting up your big little with 7 or your big little with 4. Regression's way easier. You just got to remember geometric means regression. As long as you have 2 points, you can run a regression on exponential. Quadratic, you need 3 because you need the behavior to be formed. A lot of times you need 3. But exponential, you only need 2 points. Yeah. Yeah. 79 is your semi-log plot. So first, you're looking for the y values to change by a log pattern, or an exponential pattern. 10 to the 0, 10 to the first, and this is log. This 1, 10, this is also log. These are linear, so I would cross out C and I would cross out D. Those aren't even an option. So then the next thing you got to do is look to see if these are plotted right. So 125 means that 1, this is 10. After 10, these go by 10s. So this would be 10, this would be 20. That's midway between 20 and 25, or 20 and 30. That's 25. 2, 55. This is 10. This is 10, 20, 30, 40, 55. That one matches. These would all be like between, this one is 1. So this would be like 1.5. This would be like 1.75. And then it starts to, well, even here it's still linear. These are all under 10. So this is 1, 2, 3, 4, 5, 6. So this is still between 1 and 2. This is 1 between 1 and 2. This is now between 2 and 3. So the values don't match the y's. Yes, you look at me. Yeah?
Yeah.
You know a semi-log plot?
Yes.
Okay.
Mr. President, I have a
Yeah.
question. For number 77, which one is the actual?
81, questions on these? Yeah. 81, okay, gives you a sine and a cosecant, and it asks for the points of intersection. So I literally just did. Type this one in, and this one, that one's not hard to type in. The cosecant is 1 over sine, right? Because there's no cosecant button on your calculator. So you had to write that as 1 over sine of 1.8x. And then just look where they cross. Yeah. And I would have restricted that window, sorry, to make it just from 0 to pi over 2 so it's easier to see. This is, I would do that on Desmos because Desmos might actually even let you type in, does anybody know, the cosecant. You could type in cosecant on Desmos. Yep. Thanks, Josephine. If you haven't done Desmos for at least the graphing and please try it. It is way easier to find a 0. It is way easier to pinch and zoom in and out. Like those things are way easier.
And you can also adjust the,
Yeah. Okay.
can you go back to 80?
It gave you that it said 3, 4, and 5, 8 represent consecutive minimum and maximum values. That is half your period. So if it said max to max or min to min, that is your period. If it's min to max or max to min, you're only doing half the period. So from 3 to 5 is 2, that's a half the period. So the period would be 4, and then B is 2 pi over 4.
I have a question.
First of all, your max is 42 plus 44.5. So if you want to see the max happen, you got to go up. Like make your max 90.
Because that's where it is. So it's decreasing and then it's increasing. Right?
It's decreasing because it's falling, right? And it's at an increasing rate because it's on a U.
Right, because it's
Yep.
eventually going to increase.
Well, just because it's on the U. So it's concave up.
So for that one, would you plug in 115 or you?
No, I traced it and went to 115. Found where X was 115 and looked on what part of the curve it was, which was like there. So it's on the decreasing side. So the rate, the height is decreasing, but it's on a U.
Is
So,
increasing rate the rate of change? Like increasing
Yeah.
rate of change?
Yeah.
Oh, okay.
and it would be concave up. All right, questions on 83? Switch, right? You're switching your, they gave you the domain, which means you want to get the range from the original graph because domain becomes range. Okay, 84, 85, 86.
84 and 85.
Okay, 84 says, oh, this is like one of what we've done is like, now you've seen this like 4 times where they give you 2 unknowns, right? So you don't know what C is, but you know that this would be your T and this would be your P of T. So I plugged in 6, I plugged in 3. Log, ln is the same thing as log of E if you want to convert it into exponential. So log base E of C squared times 3 gets you the equation. The E goes over, picks up the 6. E to the 6 equals C squared times 3. And then in the calculator, I would do E to the 6 divided by 3. And it actually says what's the value of P10, so you didn't have to square root it because you could have kept C squared. But I found C to be 11.596. And then I plugged that into the calculator. ln of 11.596 squared times your T is now 10. So you had to solve for C first using the coordinate point they gave you, and then you had to plug it back in with C. Yeah,
The way I did it was I just kept plugging in values for C
that works.
until I found 11.5.
It might be faster the other way, but sure. Yeah.
Wait, so C becomes 11.
C is like your constant, right? So you had to solve for C first, and then you plug it back in
Plug it back in
into the equation. Then you only have one unknown, and that unknown they ask you to get is T, which is 10. 85 says the table represents a value. An exponential regression is used to model the data. The residual in the model when x is 5 is 0.512. So what is h of 5? So I ran the regression, right? And then I predicted 5. I got y of 5, and it was 0.8898. So the regression, or the residual gives you 0.512. Residual is actual minus predicted. We don't know the actual. So I set up an equation. The x minus the predicted, which I got from the calculator, 0.8898, should have been 0.512, and then you add to solve it. And that gave you 1.4. So actual minus predicted equals your residual. You didn't have the actual this time. You can find the predicted using your model, and they gave you the residual. You gotta know it's actual minus predicted. Remember, A comes before P.
Which one tells you whether or not it's overestimate or underestimate?
So think about, if your R is positive, that means the R is over the model. The model would be an underestimate. If the R is negative, then the R is down here. The model is over. So the model is an overestimate. So the question is, where is the model? If the R is positive, then the model's under it. The model's an underestimate. If the R is negative, then the model's over it. The model's an overestimate.
So for this one, if I were to graph it on here and then do actual minus.
We didn't get to anything we were supposed to get to today. What?
If we
Okay, so this one says P of T equals ln C squared T. So this is another one. We've now had 4 where you had 2 unknowns. It's gonna happen, okay? It says that your input is P of 3 equals 6. So the 3 is your T and the 6 is your P of T. So 6 equals ln C, I don't know, squared times T, which is 3. So then I get 6 equals ln 3C squared. In order to get to the 3C squared, I have to convert this into exponential, and ln is log base E. So the E comes over and picks up the 6, and then I would divide by 3, and then in the calculator, I would take E to the 6 divided by 3 and square root it. And you get C equals, and it ended up being 11.596. Keep your 3 decimals, okay? And then I want to find P of 10. So I plug that back into the equation. P of T equals ln. My C is 11.596 squared times T. I would plug that into my Y1. And then I would find Y1 of 10. And it was 7.204. Yeah.
Technically, you didn't have to square root it, right?
Correct.
Okay.
Because it was C squared in your equation. Yep. Yeah, I caught the same thing when I was doing the work. Any other questions from this page? Okay, so it said a toy airplane travels clockwise in a circular pathway, radius of 5, which overlaps with your graph. At a constant rate, the figure above displays the path and direction of the toy airplane in XY model. Think that they could have taken this same question and made an FRQ from it. Like, you have to be able to understand it, right? You're looking for 2 things, period, and then max, min, or amplitude. So at time t equals 0, the plane is at 0.5. So here, t equals 0. That's the start. At time t equals 60 seconds, the toy airplane has completed exactly 10 complete rotations. So think the time divided by the number of rotations. So 60 divided by 10 tells you it is 6 seconds for 1 rotation. That means your period is 6. And 2 pi over the period gives you b. And b was pi over 3. So when you look at your answers, that rules out b and d. Then it said, I had to figure out if it was sine or cosine. And it said the sinusoidal is used to model the x-coordinate of the position of the plane as a function of t. So I want the y on my sinusoidal to actually be the x here. So the x starts at 5. At t of 0, it's at 5, which means I start at 5. Then it goes to where the x would be 0. Then it goes to where the x is negative 5. Then it goes to where the x is 0 again. And then it comes back to where the x is 5. This shape would be what? Cosine.
Oh, wait, so, can you explain, like, the wording?
Yep, it said the sinusoidal is used to model the x-coordinate of the position of the plane as a function of t in seconds. So your output on the sinusoidal function is the x value on this graph. That was tricky. Yeah, okay. All right, then came your FRQs. Questions on 1. Yeah.
What it says, like, decreases or increases without bound, like, decreases would be, like, negative?
Infinity, and increases would be positive infinity. Yep. When you're talking about end behavior? Yeah. So decreases is left-hand side, increases is right-hand side. Reagan?
You do 2A.
Yep.
Okay, just
So,
the first one, 2A.
the setup of the equation. Yes. It's gonna give you a coordinate point. It's disguised in some way. So it says after 1 week, the tree measured 3 feet. That means 1, 3 is my first point. And then at week 5, it's 89, 589. So this is your input. This is your output. So in this case, it gave you the equation h of t equals b, a, b, t. T is your input. So I make 1 here. 3, h of t is your output. So I make that your 3. Leave a and b alone when you're setting up your equations. And then the second one, your input is 5. That's the exponent. The output is 89. And then again, leave it alone. And then I ran the regression to get A and B.
And then can you, the second one on B?
B, interpret the meaning of your answer. So your rate of change, you have to describe your rate of change in this context. So your rate of change was 21.5. That means it's an increasing rate of change, or your rate of change increases on what? So it's bamboo and weeks. So from week 1 to 5, the height of the bamboo tree increases by at a rate of 21.5 feet per week. You got to include all the units.
Thank you.
You're welcome. All right, your sinusoidal. This time it was a piston, right? So you had to do your coordinate points. This is your guaranteed one. Okay. And then the last one. Yeah.
Are all of like the FRQs like the same like types of problems?
Yes-ish. Like 3 is the one that they are very transparent, will be sinusoidal. Your exact question will be on this, like find the coordinate points, get your A, your B, your C. 3 is the most transparent. But like this one always involves an h of x, a g of x, more than one equation. And you're always setting something equal to it or plugging something in. And you're always going to do something with a log and a trig function. And the trig function will always be one of your identities that you have to simplify. That is always happening. What could get mixed in here is an exponential. We've seen exponential in here mixed with the log. So you've seen both of those things. Number 1 is always either a chart or a picture of a graph and then an equation. And there is always a composite function. So an f of g or g of f or a negative f negative 1 of x. That is always happening. But then because it's calculator, there's always some other part where it gives you the equation, you have to find it. And then at some point, you always get a rate of change. Like you're always going to get a rate of change. It's either going to ask you to use the rate of change to predict something or compare the rate of change. That always happens too. How it changes is a little bit different every time, except for the sinusoidal. The sinusoidal is like stuck in stone. That is the one they promise you will be those exact questions.
So the second like problem when it asks you like take the rate of change from like this problem and like equal like
Use the rate of change to predict something.
yeah, how
Yeah.
do you do that?
That's when you do like y1 or y2 minus y1 over the x2 minus x1 equals the rate of change.
Okay.
And then one of those you will know and one of those you won't. So the one you don't know, you make your x and then solve your equation. Yep. All right, so it said, and it has been consistently something on this last one where it's going to give you 2 functions here. They have involved logs, they have involved trig, they have involved exponential, right? Yep. And then 2 more here, and this is the one usually you have to condense. Either it's exponential and you have to condense it, or it's log and you have to condense it, or, and then it's trig and you have to simplify it in some way, okay? And then you solve, yep. So for A, it says you got your g of x, you got your h of x. I says if g of x equals 2. So I'm going to take g of x and I'm going to set it equal to 2. So 2 equals log base 3 of x plus 4. And then I've got 1 log. I want to get it into exponential. So the 3 picks up the 2. 3 squared, this is gone, equals x plus 4. 9 equals x plus 4. And then x would equal 5. And because it had a log, we always check these answers. Because this could be, and it has been on practice stuff, like a quadratic where you have to factor it and you get 2 answers and one doesn't work. So you have to make sure you check those log answers. So that's the first one. That's I. Then it says, h of x equals 1. So now 1 equals my h of x, 2 cosine x. And now I'm in trig, so I want to divide by 2. I got the cosine of x equals 1/2. I want to give the answers on my, and it's on the interval, so I don't have to worry about adding my interval, but it's on the interval, the whole unit circle. Where's cosine 1/2? That happens at your over 3s, right? And they're positive in the first quadrant, pi over 3, and the last quadrant, 5 pi over 3. Then it goes to C. Oh no, then it goes to B, okay? B says J and K are given. Rewrite J as a single natural log with no negative exponents in any part of the expression. Your result should be in the form of ln of an expression, meaning there should be only one ln. So ln of x minus 7 minus 3 ln 2 minus 4 ln x plus 1. So personally, I do the exponents first. Like this becomes an exponent here. This becomes an exponent here. And then anything that's positive stays in my numerator. Anything that's negative goes to the denominator. So ln x minus 7 is in the numerator. 2 to the third is in the denominator. X plus 1 to the fourth is in the denominator. I think you would get full credit on that, even though the solutions changed this to 8. I still think you would get an equivalent answer, because if you left it as 2 to the third, it's still right. Then comes I, so this is I. This one says k to the x appears, or is an expression in which cotangent appears once and no other trig functions are involved. So I have to take this expression and rewrite it in terms of only cotangent. So I can, there's probably a couple different ways to do this, but I can make tangent sine over cosine. I can make cosecant 1 over sine, and I can make secant 1 over cosine. The whole goal is to get it to 1, so I know I'm going to have to combine this into a 1 like denominator. So in order to get them together, I now have sine of x over cosine of x minus 1 over sine x cosine x. And the left one is missing the sign. So I'm going to multiply by sine in the top and the bottom. Sine squared x over cosine sine minus 1 over sine cosine. And then sine squared x minus 1 goes over cosine x, sine x. And sine squared x minus 1 is from my identities. Sine squared plus cosine squared equals 1. So if I bring the negative over here, the 1 over here, and I do sine squared minus 1, then I have to bring the cosine to the other side, making it negative cosine. So I get negative cosine squared x, and I think that's probably the most common mistake people make, is keeping it positive. Over cosine x sine x. One of your cosines is going to cancel, and I get cosine x over sine x. It's negative, and cosine over sine is cotangent. Okay, that's harder than most of them, to be honest, that we've seen, and I don't think it's terrible. Okay, take a picture. I'm changing m of x to 0. 0 equals sine 2x plus square root 3 cosine x. So in these, usually you get some sort of a formula. Either sum of difference is going to show up, double angle is going to show up, which is what's happening here. So the double angle sine formula is 2 sine cosine. And then I can take out a cosine. And then I can split and solve. So where's cosine 0? At pi over 2 and 3 pi over 2. And sine of x equals negative root 3 over 2. Where is sine? Negative root 3 over 2. It's at the over 3's in the bottom. So x equals 4 pi over 3 and 5 pi over 3. Now it doesn't give you a restriction on the interval, right? It doesn't say on 0 to 2 pi, which is why you have to add 2 n pi to both of them. So if I'm giving this answer, obviously for a grader to read, I'm doing pi over 2 plus 2n pi. I'm doing 3 pi over 2 plus 2n pi. I'm doing 4 pi over 3 plus 2n pi. And I'm doing 5 pi over 3 plus 2n pi.
And it doesn't matter, like you don't have to check and see if any of them can cancel that.
No. Not in these, no. I would say, because there was nothing in the denominator, that one time that we had that, it was because of the denominator. This can even be, like, this could even be written as pi over 2 plus n pi, and you can eliminate one, but you don't need to do that work. They're not gonna mark it wrong. Make it easy for them to grade, I would say. Make sure you're circling your answers, make it neat, okay? Make it easy, because it's not like you can review your test with somebody. That doesn't happen. It's not like I put an answer in this top right corner and you didn't see it. Those conversations cannot happen. So make sure you make it easy for them.